Hello and welcome to Mr. Linford's math course. In today's discussion, we're going to be exploring the process of completing the square. We're going to talk about what completing the square is and how it's performed, but first we should go through and understand why it's being used and when to go ahead and use it. The first thing we should do when we talk about completing the square is try to understand what is the purpose of this procedure and the reason for it. Let's take a look at an example problem right here. We have x squared minus 4x minus 2 equal to 0. If we are going to solve this problem, notice that it is a quadratic. We have a degree 2 polynomial. So it's quadratic. We should be able to solve this by the zero product property. So let's go ahead and try to solve this by the zero product property. Now, when we solve by the zero product property, we need to factor down the polynomial. So let's try to factor this. Now, it's a polynomial of degree 1, so let's use our former technique of box method to help us out here. We want two binomials that get us an x squared and a negative 2, and we want these middle terms to add to a negative 4x. All right, well, what gets us x squared? Well, that's x and x. What gets us negative 2? Well, isn't that just a 2 and a 1? Maybe a negative 1 and a negative 2? But that doesn't add to negative 4. Okay, well, let me make the 2 negative, and well, that still doesn't add to negative 4. Are there any factors of negative 2 that add to negative 4? Well, hopefully you're obviously saying, no, there aren't. So we have a problem here. This polynomial is prime in the integers. Remember, boldface Z is the integers. So we don't have a way of factoring this down. This is our first instance where we come across a polynomial that we need to factor but can't. So does this mean that this polynomial problem can't be solved? Is this impossible? No, it's actually not. There is a way still of solving this, and in fact there should be. There are solutions to this problem. In fact, there are two. The fundamental theorem of algebra says you have two solutions to this problem, okay? But how are we going to go and find them? How are we possibly going to find these solutions to the quadratic equation? Well, that's where completing the square comes from. And completing the square is a very clever way of performing factoring. So when do we go and use this method of completing the square? What's the purpose to it, or how can we decide when to use it? Well, I guess we could say that we want to use it when the quadratic equation has a polynomial that cannot be factored in the integers. Now, this polynomial, knowing that it has solutions, this problem does in fact have answers to it. The fundamental theorem of algebra tells me that there are answers. In fact, there are two answers. I know that this polynomial can be factored. It can be broken down into two binomials. In fact, each of them will have an x. The trouble is what comes next. They might have decimal answers. They might have square root answers. They might have complex answers, right? The trouble is there's not really a standard way of determining those from our normal method of factoring. Instead, what we're going to do is we're going to use this new process for helping us out. Now let's go and actually explore the process of completing the square. I have the step-by-step process written down for us so we can follow along and see how this example problem can in fact be solved using this technique of completing the square. And at the end, I'd like us to review the steps and try to understand what's the goal of this process and maybe shed some light on why it's called completing the square. Now, before we begin, the first thing that we have to do is make sure the quadratic that we're factoring is in the proper form. We really want our quadratic to be of x squared plus bx plus c. Meaning I want a quadratic polynomial where the leading coefficient is a 1. That's important. We need it to be a 1. We'll see later on why that is. Then we can have our standard b and c, standard of other numbers. So let's remind ourselves here, b is what? Well, that's a -4, and c is a -2. Remember, because this can be plus -4 plus -2. So just remind yourselves of that. Just like when we were doing AC method, the a, b, and the c are the same here, except a is just a 1. Also, please remind yourselves that when you solve a quadratic equation, it needs to be set equal to 0. Just like when we use the zero product property, we got to do the same thing here. Make sure it's set equal to 0. Now, when we go ahead and start solving this, the first real step says to subtract c from both sides, meaning get the value of c to the other side. So if I have plus a -2 here, I better just add 2 to both sides. And let's see what we get. X squared minus 4x, these cancel out, is equal to 2. That's really what it's saying. Just get c to the other side. Okay, easy enough. Now the next step is where things get a little tricky for people, or people tend to get a little overwhelmed. We need to add to both sides this value b/2 squared. Now this is a little odd, but it's not impossible. We'll see why this is important in a minute. Let's first identify what b is. B is -4. Okay, let's take, and I might do this on a little side work here. Let's take -4 and let's divide it by 2, and then we'll square it. Well, -4 divided by 2 is -2, and when we square that, we get 4. Okay, so that's the number we have to add to both sides. And let's see what we get here. So let me clear some space. I'm going to add 4 to both sides. Plus 4 and plus 4. We end up with an x squared minus 4x plus 4, because none of these are like terms, so they don't combine, equals, well, these actually do combine. That makes a 6. Okay, I guess that's fine. Here's where all this work really comes together. We need to now factor the polynomial that we've created. This polynomial can be factored down because of this very ingenious way of adding half the middle value squared. Let's take a look at this for a second. Let's try to see why this polynomial can be factored down into this. So I'm going to use the box method here, and I want to make sure I have enough space for us to see what's going on. We are attempting to factor, I'll first use the numbers. X squared minus 4x plus 4. X squared and a 4. I need to think what multiplies to give me 4 but adds to give me -4. Well, first off, what gives me the x squared? X and x. What gives me +4 but adds to -4? Well, isn't that whatever half of this is? And then negative? So -2 and -2 to get -2x, -2x. Hey, it works. Remember, the value I had for b/2 was -2. And then when I squared it, I got the 4. That's why this is working. It's essentially saying that you are forcing this polynomial to have a value that can be factored down and still have things add to it. Let's try this example one more time, but this time let's take a look at it where we have the actual symbols. Let's try to factor this down. I'm going to do the box method again. Now, we're going to first say, all right, we're going to end up with an x squared, and we're going to end up with a b/2 squared. Now we need to think, what gives us x squared? X and x. Easy enough. We also need to think, what can multiply to get us b over 2 squared, but add to get us the bx? Well, the big thing here that we need to say is, how do we get b over 2 squared? One way is by multiplying it by itself. B over 2 times b over 2, that's what it means to be squared. And notice that b over 2 plus b over 2 gets us the b value. This is forcing the polynomial to be factored down. We are, in picking this unique value of b over 2 squared, we're forcing the polynomial to be able to be factored. Hopefully this is starting to make sense to you. The idea here is that we're forcing it to be factored using the squared value. So we end up with an x minus 2 times x minus 2 equaling 6. All right, we factored it down. We have x minus 2 times x minus 2. We got the same thing twice, hence the completing the square, because we can write it as x minus 2 squared equals 6. Now, with this able to be factored down, and we have x minus 2 squared equaling 6, remember, we still have to solve for x. We still have to get x by itself on one side. So how do we do that? Well, in the previous step, some people think, oh, use the zero product property. But wait a minute. 6 isn't a 0 here, so that doesn't work. Instead, how can we isolate the x? Well, one way, take the square root of both sides. We'll end up with x minus 2 equals the square root of 6. And then we can add 2 to both sides, and we get 2 plus or minus the square root of 6. Remember, there are two possible roots here. 6 could be the positive or the negative version. So when I add 2 to both sides, I can either take the square root of 6 and add 2 to it, or I can subtract it from 2. And here is our final answer. These are the two solutions to our problem. Remember, quadratic equations will have two solutions. That's what the fundamental theorem of algebra says. So, this is a way that we can go and find them. When we square both sides, when we take the square root, I should say, of both sides, we have both the positive or the negative version, and when I add 2 there, we get both of our values. Hopefully this process is starting to make a bit of sense to you. You're seeing kind of this pre-work that we're doing just to be able to get the polynomial to, in fact, factor down. It's a very clever trick that's going on here. So make sure that you're feeling okay with this, and let's go ahead and solve the next problem. Now what I'd like you to do is try to solve these two practice problems on your own. Pause the video and take a couple minutes to do this. If you need, go ahead and flip back to the step-by-step process, see how it was done individually, but really try to make sure you're understanding what's being done here so that we can get the polynomial to factor down. Because if you notice right away, there are no numbers that multiply to give you 13 that also add to give you negative 6. So our standard methods won't work, so we're going to need to use the completing the square here. Again, pause the video, take a couple minutes, and give this a try. All right, before we finish up the problem, I want to take a quick minute to make sure that we're comfortable with the first few steps, and what I call the setup steps. Notice that I am identifying here what my a, b, and c are, and I'm making sure that the polynomial is in the form that we want. Then, as we go through and start working, I moved the c over, the negative 13. Then I did this to the side, what that b over 2 squared value is. That's the 9. So I added 9 to both sides, and notice that I was able to combine the like terms. Now is where I want to go and actually factor down. So again, pause the video, finish up this problem if you haven't yet, make sure that you're in the correct spot if you need, and then we'll check back in and see what we got. All right, well, hopefully you were able to finish out this problem, but if not, take a look here. Notice that the first thing that we did was went down and factored the polynomial that we created. Okay, when we factor down this polynomial, we got an x minus 3 squared. You can find that doing simple box method. Then we said, okay, if we have this entire equation here that we need to go and solve for x, well, I decided that the first thing I would do is get rid of that squared, because we got to get x by itself on one side. Can't do anything with it while it's trapped in that exponent. So to undo the squared, I took the square root of both sides. Well, then I ended up with the plus or minus the square root of -4. And then I said, well, we can add 3 to both sides. So I had 3 plus or minus the square root of -4. But remember, the square root of -4 can factor down into 2i. Okay? Recognize that in this problem, we have just factored down the polynomial and solved for the values to it. And those values that we got are 3 plus 2i and 3 minus 2i. We got two complex numbers. So I want to take a minute and I want us to see how this problem, this polynomial, really was supposed to be factored. We had an x squared minus 6x plus 13 equals 0. And we couldn't think to ourselves, what factors of 13 get us -6? There weren't any in the integers. Turns out there aren't even any real numbers that do that. Instead, we would factor this down to be x plus 3 plus 2i. Remember, this is like one number here. And x plus 3 minus 2i. Those would be the factors. And the factors here are contained in complex numbers. So we really need the complex number system to factor this down. That's why I said before, polynomials really aren't prime, okay? The only true prime polynomials are the linear ones, the things that don't factor down, because they don't have any factors other than one in themselves. Instead, any polynomial that you work with might just be prime in a particular number system. You would have to expand it outwards even more. For us, this problem needed to be expanded out even into the complex number system. So hopefully you're seeing why that works and you're able to see the case for these solutions. And remember, you do need two solutions because this is a quadratic. It's a degree 2 polynomial. The fundamental theorem of algebra says we need two solutions. Now let's take a look at the next problem. As you see in this problem, we have the polynomial 2x squared minus x minus 3, and that's being set equal to 0. So we solved, or I should say we simplified the initial problem to get this quadratic equation. All right, let's go ahead and do the completing the square process. Oh, but wait a minute. In this problem, we are not allowed to use the completing the square. The reason for that is because the first term is a 2. The first term needs to be a 1. I should say the leading coefficient, anytime you're going to do completing the square, must be a 1. Otherwise, this process for factoring really doesn't work. So you might say, uh-oh, we're kind of stuck here, aren't we? How are we going to go about and perform this task? Should we try factoring it again? I guess completing the square won't always work. Well, that's actually not true. We could probably go and try to factor this, but what I'd like to do is keep going ahead with completing the square. Remind yourself that the first step in completing the square is just to make the leading coefficient a 1. And how do we go about doing that? Let me clear some space here, and let's give this a try. So this original problem, we were able to simplify. Now, how do we go about and getting this coefficient, this leading coefficient, into a 1? How do I end up with a 1x squared here? What would the rest of everything be? Take a minute, pause the video, and give this a try. Well, hopefully you're noticing that the quick and obvious way of getting the leading coefficient to be 1 is just to divide both sides of the equation by 2. That's allowed. So we end up with an x squared minus 1/2 x minus 3/2 equaling 0. All right, I guess this is fine. Well, it's in the form that we want, so we're going to have to work with it. We're going to have to deal with fractions here. All right, so let's start solving like normal. We're going to add the negative 3/2 to the other side, so we have x squared minus 1/2 x equaling 3/2. Now we're going to have to do that thing where we take the b term, we divide it by 2 and square it. So I'll do that over to the side here. Let's take negative 1/2 and divide that by 2 and square it. Well, negative 1/2 divided by 2 is the same as multiplying by a half. So isn't that just negative 1/4? And squaring that, isn't that just positive 1/16? So I guess we could say, well, we can add 1/16 to both sides. Now, on the right-hand side, we can combine the like terms, so we can take 3/2 and we can add that to 1/16. I'm just going to use my calculator and the fraction feature on it to add those together, and we end up with an x squared minus 1/2 x plus 16 equaling the 25/16. All right, we've done all the steps that we need to. Now we have to go and factor this polynomial down. Well, we can use the format, but let's try box method really quick. Let me clear some space here. And before we just go ahead and put an answer down, let's see if we can try to reason out one. We need to first end up with an x squared. We also need to end up with a 1/16. And we need these things, these middle terms, to add together to give us a negative half, or a half x. So what things can multiply to get us 1/16 and add to get us negative half? Well, hopefully you're saying that was just negative 1/4 and negative 1/4. It's the square root of 1/16. So what multiplies to give us 1/16? A fourth and a fourth. But we need them to add together to give us negative half, so negative 1/4 and negative 1/4. Those are the factors. X minus 1/4 times x minus 1/4 equals 25/16. This is really this setup that we're going to have when factoring this down. And again, you could always just skip ahead. Even when it comes to these complex problems, you can just use the formula that we had back in the start. Remember, our process said that when you factor it down, the factors are going to be x plus whatever b over 2 was, okay? And include the sign with it. So let's go ahead and keep solving this. We have x minus 1/4, and we should take the square root of both sides, so we get plus or minus 5/4, because that's what 25/16, the square root of that is. And then we can add 1/4 to each side to get 1/4 plus 5/4 and 1/4 minus 5/4. That's a tongue twister. 5/4. So in fact here we can actually get a solution. We can say that's going to be 6/4 or -1. That's what I get when I add a fourth to 5/4 and when I subtract 5/4 from a fourth. So here are my two solutions. Again, all that we're doing is getting the formula in the form that we want. If it's not in the form that you want, just divide everything by that leading term. Doesn't matter how complicated it will make it, we are still going to, by very carefully picking values to add to both sides, we are still getting the polynomial to factor down, okay? No matter how complicated it looks, we're picking it in a very specific way so it can still be factored. Once we factor it down, we have a fairly simple equation to solve. All you have to do is take the square root of both sides and add or subtract the value over to it. That's pretty much it. Just remember, there's always two solutions that you're going to have in the end here. With this idea of working with fractions, let's go ahead and let's try another problem that in fact deals with fractions. A lot of people would want to start by naturally saying, hey, let's clear all these fractions. Let's multiply both sides by 49. If I do that, I get 49t squared minus 14t minus 5 equals 0. Hey, there we go. We factored it, or we got it to where we cleared all the fractions. But wait a minute. Can we do completing the square on this? No, because that first term isn't a 1. Really, we have to be comfortable leaving the problem as is. As long as the leading term here is a 1, we want to leave it as is because we have this very ingenious way of getting it to factor down. Now, looking at this, I don't want to go and necessarily try to factor everything dealing with fractions. That's going to be a bit messy, and why waste the time? Instead, let's go ahead and complete the square. I want you to pause the video, take a minute, and really try to make sure that you have this method down for how you go ahead and complete the square. All right, well, let's take a minute to first make sure that we are starting off with the correct values that we need. Notice that I first added the 5/4 over, just like we're normally doing. Then I had to figure out what this middle term was when I divide it by 2 and then square it. So you can see off to the side here with the green writing, I took negative 2/7 and divided by 2. Well, that's just the same as negative 2/7 times a half. So that's negative 2 over 14. And when I square that, the simplified fraction that I got was positive 1 over 49. So I've gone and added that to both sides. Hopefully you got these values. If not, adjust some of your work, and then let's continue solving the problem from here. So pause the video and keep trying to factor the problem down from here. All right, well, hopefully you're able to go through and factor down the polynomial that we worked with. Notice that when I factor this down, I'm really relying on what that b over 2 value was. That b over 2 value is the term that we're really going to work with. So when I factor down the large polynomial, I got t minus 1/7 squared. That whole thing squared. And that equals 6 over 49. Now, I then need to square root both sides. So I get t minus 7 equals, well, the square root of 6 over 49 simplified to the square root of 6 over 7. I can't break down the square root of 6 anymore, but that's fine. Don't expect it necessarily to, right? A lot of time these polynomials that don't factor down, they're going to have square roots in their answers. And that's okay. We expect that to happen. So then all I have to do is add 1/7 to both sides. So we end up with 1/7 plus or minus the square root of 6 over 7. Or you could just say, if you wanted to write it as one fraction, 1 plus or minus root 6 all over 7. Again, hopefully you're feeling comfortable with this process. You're seeing the step-by-step process that we need to do. And hopefully you're comfortable getting these rather complicated polynomials to factor down. When in doubt, you can just use the formula if you need. But really want you to start seeing how we're structuring this to in fact make the polynomial be able to factor down into something squared. If you have any questions or would like me to review any of these concepts, please let me know. My email is klinford, that's KLINFORD @wccnet.edu. And until next time, take care.